Hey guys, so in this screencast, we'll discuss the NODAL analysis. So we have been given this problem to come up with a value of I/O. So now to come up with a value of I/O, we must apply the NODAL analysis in this problem. So as usual, NODAL analysis, it is the modified uh, KCL. So we need to come up with the KCL equations. Then we apply our Ohm's law. We substitute where there is current. We substitute with resistance and voltage. Current in terms of resistance and voltage. Yeah. So in this case, we have been asked to determine this VO. So in order to determine the value of VO, so first of all, in this circuit, we need to assign the current. So I will assign this current as I1. Then this current here will be my, this current will be my I2. It will be my I2. Then here I'm also assigning a current of I3. Even here I'm assigning the current, so this current will be I4. This current is going to be I4. So let me do this. So this is I4. So that's the value of the current there. So the current is in I4. So we have I4 there. So now let me do this again. So here I need to assign this as node 1. So let us assign these nodes to be this one 1, this one will be node 1, this will be node 1, this is our node 1, so 1, then this will be our node 2. So these are the nodes. So if I say it's at node 1, what is happening at node 1? So at node 1, so what is happening at node 1? So node 1 we have the current. So at node 1 we have the current I1 entering the node. I2 here is leaving the node, as you can see from here, from this node. From that node we have I1 entering, going in this direction. I2 is leaving, this is I2. I4 is leaving as well. So let us move in that accord. So we say I1 is entering, so we assign it a positive sign. Then we have I2 there coming out. So what is coming out will be having negative, and what is going in that at that node is will be assigned with positive signs. So in this case, I2 is leaving and I4 is leaving as well. So these will have what? Negatives. So all these must be equal to 0 according to Kirchhoff's current law. So my I1 is equal to, so now having this Kirchhoff's current law. So my I1 is given by, so we know that current flows from the region of high potential to the region of low potential. So we do have, so what we get is, so we get, replacing there, we get 30 minus V1 divided by the resistance is 1, minus, so minus, so I2, so my I2 there is is equal to V1 over 2. So here is my I2. So is equal to this V1 here. So voltage 1, the voltage at node 1, divided by 2 ohms. So we move. So I4. So on I4, we do have voltage at node 1. So the voltage at node 1. Now, here we have the voltage source. So we have the voltage source. So on the voltage source here, we have the voltage drop. Since current is entering the positive terminal, we have the voltage drop. So current is supposed to enter through the negative terminal and leave through the positive terminal. So now it is entering through the positive terminal. So there it is a voltage drop. We have a decrease in voltage. So we subtract. So we say we have got V1 minus 2V or minus V2. So minus this voltage again, which is V2 here. So all these divided by what is the resistance there. So here we have a resistance of 4. So we divide by 4. So all these are equal to 0. So all these are equal to 0. So let me copy this equation somewhere. So what we have is we have 30 minus V1. Then we have V1 over 2 minus so there in the bracket we have V1 minus, so where there is VO, so VO is the same as V1, so this VO is the same as this V1, so it's one on the same. So where there is VO, I have replaced with the initial values that I have assigned on my own. So I'm going to replace with V1. So this is 2V1. So minus V2 divided by 4. So all these must be equal to 0. So there, reducing, we get this minus this, divide 2. So we know that V1 minus V2, I mean V1 minus 2V1 is equal to negative. So we are having negatives inside the bracket. So when we multiply throughout by the negative sign, we are getting positive. So we say it is V1 plus V2 there. Divide 4 equals 0. So 4 is our common denominator. So we can multiply throughout this expression throughout by what? By 4. So if we multiply throughout by 4, we are getting we have 120 minus 4V1 minus 2V1. So this 4 multiplied by 30 is 120. 4 times V1 is equal to 4V1. 4 times half V2, we get 2V2. Then 4 times this, the 4 and this will cancel, we just cancel. So we are just copying what is on top. So in this case we get we have V1 plus V2 equals 0. So we can collect the like terms. So collecting the like terms, we do have this. So this minus this is so negative 4 minus 2 is negative 6. Negative 6. So negative 6 plus 1, we get 5 V1 plus V2 is equal to 0. So what we are getting now is so we can write this as 5V1 minus V2 equals 120. So this is as simple as equation 1. So having that as my equation 1, I can now move to to node 2. So at node 2, so at node 2, so what am I having at node 2? So at node 2, sure, let me go back a bit. So this is the node that I'm talking about. So at node 2, we have this current entering. So I4 is entering. This I3 is leaving. Then this 3 ohm resistor from the current source is entering. So two currents are entering, which is I4 and the 3 amp. The 3 amps is entering. Then one current is leaving. So which current is leaving? So I3 is leaving. So what is leaving is I3. So we say we have got I4 entering, I3 leaving. So if I3 is leaving, then it has to be assigned the negative sign. Then the 3 amps is entering. So all of this must be equal to 0 according to the case CAO. So in this case, let me now replace with the voltage and the resistance. We replace with the current in terms of voltage and resistance using the Ohm's law relationship. So we all know that up to now we now replace. So we know that I4 is simply equal to V1 minus 2V1 minus V2. So we are just borrowing a leaf from the assumption that we made earlier, from the current that we determined from this part, the current that we determined from this section, that expression we are just rewriting, which is this expression. So we are just rewriting. So in this case, let's go back to our problem. So minus, so our I3, is equal to, which one is our I3? Our I3 is here. So our I3 is simply V2 divide 16. So our I3 is V2 divide 16. So we have got V2 over 16. Then plus 3. The all of these must be equated to 0. So we now have so we now have 16 as our common denominator. So okay, let me just reduce a bit. So we have got negative V1 minus V2 equal to minus V2 equal to, let me go back a bit. Okay, minus V2 over 4 minus V2 over 16 plus 3 is equal to 16 is equal to 0. So let us multiply this throughout by 16. So multiplying throughout by 16, we get 4V1 minus 4V2 minus V2 plus 16 times 3 is simply 48. So what we get is, now we have this and this. So we have got negative 4. We have got negative 4V1 minus 5V2 plus 48 equals 0. So it's just a matter of collecting the like terms. So we have collected the like terms already. So now it's just a matter of dealing with the sign distribution. So let us omit all these negatives by crossing the equal sign. So if we cross the equal sign, we do have 4V1 plus plus 5V2 equals 48 now. So this as my equation 2. So now let us solve these two simultaneously. So let me bring my equation 1 here. So where did I keep my equation 1? This is my equation 1. So 5V1. So it goes as 5V1 minus V2 equals 120. So if I was to make this is my equation 1, so I must solve these two simultaneously. So if I was to say uh, where there is v1, v2, I make v2 the subject to the formula from equation 1, v1 minus 120. So v1 minus 120. So in this case, we get so where there is v2 in equation 1, in equation 2, I must replace with this. So in this case, we get we have got we have so in this case we are getting, oh sorry guys, sorry. So yes, so in this case what are we getting? So what are we getting? So where are we? So what are we getting? So we are here. So what are we getting? So we are getting so I start replacing v1 plus this, then we get 5 minus 120 equals 48. So in this case replacing now, multiplying throughout by 5, I'm getting 5 times 120 is 600 plus 25 v1 equals 48. So this and this we get, so we get 29. So this is 29 v1 equals 48 plus 600. So we get so we are getting 648 there. So if we divide throughout by 29 over 29, so over 29, so we are getting v1 as in, so v1 as in 22.34. So that is our v1. So our v1 is equal to 22.34, but v1 is equal to vo, which is 22.34 volts. Yeah, so this is our answer that we are getting from there. So thank you so much guys, and have a blessed day.